Hello friends, there are two more videos in this series. Okay, so for this chapter I have already made two more videos, part 1 and part 2. Please observe that and then come to this video. So this is uniform circular motion. So observe the tip of the second hand of the clock. So if you look at the clock, घड्याळ जर बघितलं तर त्याच्याकडे दोन हात आहेत. Two hands are there. One is second hand and another is minute hand. That you can observe. There is hour hand also, but second hand, if you see, it moves very fast. So what can you say about the velocity and its speed? So the speed of the tip is constant, but the direction of, that is the displacement, is changing continuously. It is changing. So as the tip of moving along the circular path, its motion is called as uniform circular motion. So you can see this pencil, they have done one activity. So you can draw a rectangular path. Now you have to take the tip of pencil and you have to start drawing it. How many times do you change the direction? For rectangle, for pentagon, for hexagon, and then for circle, how many times do you change the direction? So when you draw a circle, you are continuously changing the direction. At every point, you are changing the direction and then only you can draw a circle. So when an object is moving with constant speed along a circular path, the change in velocity is only due to change in direction. So consider the tip of the fan blade. The fan blade is moving and the tip of it is performing circular motion. Now if the fan is at a regular speed, a constant speed, then we see that the tip or the point on the blades, they are performing uniform circular motion and they are changing direction continuously. Okay, so if an object moving along a circular path of radius r is taken, speed is equal to what? Circumference upon time. Circumference म्हणजे काय? 2 pi r. Formula आहे ना, circumference of circle 2 pi r. So 2 pi r upon t, that is the formula for speed. So accelerated motion, whenever an object moves with a constant speed along a circular path, it is uniform circular motion. So we can see one more example here, determining the direction of velocity in uniform circular motion. So suppose you have a disc and that is moving continuously and you keep a coin over it. What will happen? The coin will go tangentially to the direction, tangentially around the tangent. That is because the direction of every point on this disc is along the tangent. Now, if the coin is kept on this rotating disc, what will happen? It will be thrown off in the direction tangential, which is perpendicular to the radius of the disc. Thus, the direction in which it gets thrown off depends on position of moment of getting thrown off. It means that the coin moves along a circular path and the direction of motion is changing at every point. Now, an athlete is running a circular track. He runs 400 meters in 25 seconds. 400 meters in 25 seconds before returning to its original position. So what is the average speed and velocity? So total distance traveled, that we can calculate, that is 400 meter, that is already given, and average speed is total distance upon total time. 400 upon 25, that is 16 meter per second, and average velocity is 0. That is because the athlete comes to the same position, starting point and ending point is same. He is running in a circular track. Now an aeroplane taxis on runway for 30 seconds with acceleration 3.2 meter per second square. So how much distance would it cover on the runway? So acceleration is change in velocity upon time, that is 3.2 meters per second square, and we have to find the distance covered. So S is equal to ut plus half at square. We put all the values, we get the answer 1440 meters. Now let us go ahead, simple examples are there, you can see. Now let us come to Newton's laws of motion. So first they have asked some questions. So what could be the reason of the following? First one, a static object does not move without the application of force. कुठलीही गोष्ट स्वतःहून काय हलणार नाही. ओके, अ स्टॅटिक ऑब्जेक्ट म्हणजे जर एक गोष्ट असेल समजा एक बुक असेल तर ती बुक काही स्वतःहून हालचाल करणार नाही. द फोर्स विच इज सफिशियंट टू लिफ्ट अ बुक इज नॉट सफिशियंट टू लिफ्ट द टेबल. तर ज्या फोर्सनी तुम्ही हळूच आपल्या हाताने 2 बोटांनी सुद्धा बुक उचलू शकता, पण तेच जर तुम्हाला टेबल उचलायचं असेल तर जास्त फोर्स लावायला लागते. सो फ्रूट्स ऑन द ट्री फॉल डाऊन वेन ब्रांचेस आर शेकन. Then electric fan keeps rotating even after it is switched off. For some time it rotates a little bit and then it stops. Why doesn't it stop immediately? For that we are going to learn Newton's laws. So Newton's first law of motion. So fill a glass with sand, keep a piece of cardboard on it, keep a 5 rupee coin on the cardboard. Now strike the cardboard with your fingers. Observe what will happen. The 5 rupee coin will fall inside and the cardboard will fly off. Now what is happening? So cardboard where is the thing on which you have applied a force, but that force is not moving that coin. The coin instead falls inside. Now balance and unbalanced force. Now suppose there is a bench and on both sides there are two students. On one side one student, on other side one student, and they are pushing each other's side. So one is pushing the bench on this side, other is pushing the opposite side. With the same force, what will happen? The bench is not going to move. So that kind of force is called as balanced force. Now when both of them are on the same side and they try to push the bench, what will happen? The bench will go ahead. That is because there is unbalanced force. So an object continues to remain at rest or in uniform motion along a straight line unless an external unbalanced force acts on it. So if something is not moving, it will remain like that. It will remain at rest. If something is moving, it will keep moving with the same velocity until somebody disturbs it, until some external unbalanced force acts on it. Now you might ask how. Okay, we have understood that if a stone is not moving, unless you touch it, unless you apply force it on it, then only it will move. Okay, understood. But what about things which are in motion? Suppose a football is moving, suppose a car is moving, and it should continue maintaining its motion according to Newton's first law. But why does it stop? Reason is friction. If you go in space and throw something, it will continue its path until something comes in between and stops it. Some external unbalanced force is applied on it. Then only it is going to change direction. Otherwise, it will continue in its path. So when an object is at rest or of uniform motion in a straight line, it does not mean that no force is acting on it. Actually, many forces are acting on it and the net force is zero. I gave you the example. So this law is related to inertia. So what is inertia? Inability of an object to change its state of motion on its own. So a moving object will continue to move on its own and a stationary object will continue to be in rest. Okay, so when we talk about friction, then we come to know in space everything, there is no friction, it will go on with the same velocity if you throw something. Okay, so let us go ahead to Newton's second law of motion. Ask your friend to drop a plastic and a rubber ball from the same height. You catch the balls. Which ball is easier to catch and why? Ask your friend to throw a ball towards you at a slow speed and try to catch it. Now the same ball with high speed towards you and try to catch it. Which is easier and why? So we have two examples. One is plastic ball and rubber ball. They are released from the same height. So they will be having same velocity. When it is coming down, you are trying to catch it. So the plastic ball is lighter in weight, easy to catch, and the rubber ball is heavier and it will be difficult to catch. A slow ball coming towards you, easy to catch. A fast ball coming towards you, difficult to catch. That is because of momentum. So what is momentum? Momentum is a property which is related to mass and velocity. So in simple words, you can say momentum is the product of mass and velocity. So rate of change of momentum is proportional to the applied force and the change of momentum occurs in the direction of the force. Now let us take a simple example. Suppose you have a football and you kick the football. What will happen? When you are changing its momentum, you are applying some force and the football is going to go in forward direction. So that is in the direction of the kick. If you kick it in forward direction, it will go in forward. Okay, if you kick it sideways, it will go that direction. So depending on the direction of the force, the rate of change of momentum is going to happen. Okay, so rate of change of momentum is directly proportional to applied force and takes place in the direction of the force. So momentum P, that is equal to mv, that is the formula. Now rate of change of momentum is equal to change in momentum upon time. Momentum म्हणजे काय? Mass into velocity. Now let us consider initial momentum mu and final momentum mv. So change in momentum will be mv minus mu upon t. Okay, change in momentum is mv minus mu upon time. That will be rate of change of momentum. M is common, so take it out. V minus u upon t is a. V minus u upon t is a, that is acceleration. Now, according to Newton's second law, rate of change of momentum is proportional to force. So, F is equal to K ma. Okay, so K is nothing but 1. Suppose we take constant as 1. So, F is equal to ma. This is the formula. So, force is equal to mass into acceleration. Now, here we come to the definition of 1 Newton. Now, unit of force is Newton. So, what we measure force in? We measure it in Newton. So, what actually is Newton? So, suppose you have an object of 1 kilo and you apply some force on it and it moves by 1 meter per second square acceleration. Okay, there is acceleration 1 meter per second square. Then the force that you have applied is 1 Newton. समजा एक किलोचा समजा ऑब्जेक्ट आहे, त्याला तुम्ही फोर्स अप्लाय केली आणि तो पुढे जायला लागला, त्याची ॲक्सेलरेशन 1 मीटर पर सेकंड स्क्वेअर आहे, तर तुम्ही लावलेली जी फोर्स आहे ती 1 न्यूटन आहे असं तुम्ही म्हणू शकता. सो CGS unit is 1 dyne. So 1 dyne is 1 gram into 1 centimeter second square per centimeter per second square. So if you have one object of mass 1 gram, you apply some force to it and then it starts moving with an acceleration 1 centimeter per second square. That is called as 1 dyne. Next we have Newton's third law. Now take a plastic boat, make a hole and its rear, inflate a balloon and fix it. So release the boat in water, what will happen? The air will slowly come out of the balloon and the boat will be pushed forward. Why this happens? Because action and reaction. Now in nature, forces are always in pair. There is always action and there is reaction. So every action force has equal and opposite reaction force which act simultaneously. So all these forces, they are equal and opposite. Here they have given us. So this is related to Newton's third law of motion. Remember this, learn this. प्रत्येक ॲक्शनला रिॲक्शन असते. यालाच आपण म्हणायचं आहे न्यूटनचा तिसरा लॉ. So action and reaction are terms that are express forces. They act in pairs. Action and reaction force act simultaneously. So action and reaction force acts on different objects. They do not act on the same object, hence they do not cancel each other's effect. So while hitting a ball with a bat, the speed of bat decreases. Gun recoils, that is it moves backward when bullet is fired, and mechanism of firing of rocket. All these things are related to Newton's third law. Okay, so all these related to Newton's third law. So when you hit a ball, what will happen? There is action and there is reaction. Action is that the ball will go forward and the bat will go backward. When the gun recoils, the bullet goes forward, the gun goes backwards. Firing a rocket, the rocket goes upwards, the gases go downwards, like this. Okay.